Math 8, Unit 9, Lesson 7, Part 1. Multiply numbers written in scientific notation. So first, we need to talk about putting things in scientific notation when they're not quite in scientific notation, but they're close. Like 478 times 10 to the third. This factor is too large, so we need to change it by moving the decimal to just after the 4, making it 4.78. Now what technically happened with that is I just divided by 100. Now to make it equal to the same thing, I also need to multiply back by 100, which is 10 squared. This gives me 4.78 times 10 to the 5th. Now it's good to think about this in terms of balance. The factor got made smaller by 2 places, so the exponent gets made bigger by 2 places. So it balances out. Let's look at a couple more quick examples here. 0.5 times 10 to the minus 3. 0.5 can become 5. That actually got bigger by 1 place. So to balance it out, this needs to get smaller by 1 place. Negative 3 minus 1 is negative 4. Okay, 31.9 times 10 to the 14. This needs to become 3.19, which made it smaller by 1 place. This needs to get bigger by 1 place. 14 becoming 15. 5,245.1 times 10 to the minus 4. This needs to be changed to 5.2451. And because that got smaller by 3 decimal places, this one needs to get bigger by 3. Negative 4 plus 3 is negative 1. So this is 5.2451 times 10 to the minus 1. Do a couple more examples. 36.9 times 10 to the 4th. We're going to change this to 3.69, which made it smaller by 1 position. This needs to get bigger by 1 position, making it 10 to the 5th. 3.69 times 10 to the 5th. 0.059 times 10 to the minus 11. This needs to get bigger by 2 positions. So this gets smaller by 2 positions, making it 10 to the negative 13. Okay, now let's take a look at multiplication. That's our goal. First, let's do it in using the standard algorithm by hand. On this, we can't do anything with these first 3 zeros because they are 0 times anything 0. But I can go to the 5. 5 times 0 is 0. 5 times 0 is 0. I'm going to run out of room here, so I'm going to move this over just a tad. 5 times 0 is 0. 5 times 0 is 0. 5 times 0 is 0. And 5 times 3 is 15. Giving me 1,500,000,000, or 1.5 times 10 to the 9th power. Now, let's take a look at it using exponent rules. With exponent rules, we've got 3 times 10 to the 5th, multiplied by 5 times 10 to the 3rd. 10 to the 5th and 10 to the 3rd are being multiplied, so we can add their exponents. They have the same base. And 3 times 5 is 15. So this is 15 times 10 to the 8th. Do the fixing it real quick. This got smaller by 1, so this needs to get bigger by 1. We get 1.5 times 10 to the 9th, which is the same answer we got before. So we can multiply using exponent rules. We can also divide using exponent rules, but first, let's take a look at it doing it by hand. 3 times 10 to the 17th divided by 5 times 10 to the 5th. So I'm dividing by 500,000. I'm going to move this decimal 5 places, so I'm going to end up dividing by 5 instead of 500,000. 5 goes into 3 0 times. 5 goes into 30 6 times. Remainder 0. So these are just going to be zeros. 5 goes into 0 0 times. 5 goes into 0. All these are just going to be 5 going into 0 0 times. And then throw in some commas just to see how big it is. Looks like it's 600 billion. That's 6 times 10 to the 11th power. Okay, let's see what happens if we divide using exponent rules. You're going to do the 3 divided by 5, and you're going to do the 10 to the 17th divided by 10 to the 5th. This is 0.6. See, scientific notation doesn't have fractions in it. So 3/5 is 0.6, and then multiplied by 10 to the 17 minus 5 is 12. Now this is not in scientific notation, so we fix it. 0.6 becomes 6, getting bigger by 1 place, so this needs to get smaller by 1 place. It's 6 times 10 to the 11, which is the same answer got before, without having to keep track of all of those zeros. So generally speaking, when you multiply numbers in scientific notation, you multiply the coefficients or factors and add the exponents together. You can see the factors being multiplied together there in blue, and the exponents being added together in red. Now down here it is not in scientific notation, so it gets changed. The 19.6 becomes 1.96, and the 10 to the 10th becomes 10 to the 11th. The blue getting smaller and the red getting bigger, so it balances out. Now when dividing, you're going to divide the coefficients and subtract the exponents, as you can see here. So for the notes, I can do operations on numbers written in scientific notation. To multiply numbers in scientific notation, you're going to apply the rules of exponents. Multiply the factors and add the exponents. Change answer to scientific notation if necessary. To divide numbers in scientific notation, you're going to apply the rules of exponents. You'll divide the factors and subtract the exponents. You want to change to scientific notation if necessary. Let's go over a couple examples. Evaluate each, round to 3 decimal places of accuracy. So 2.998 multiplied by 3.1536. That's multiplying the factors together. 9.4544928 is as much as my calculator tells me. 10 to the 8 and 10 to the 7. 8 plus 7 is 15. It is in scientific notation because there's only one number in front of the decimal point, but I do need to round to 3 decimal places, so this is 9.454 times 10 to the 15th, and that will be my answer in scientific notation. Okay, let's do a division. 1.536 times 10 to the 4th divided by 3.11 times 10 to the minus 3. I'm going to need to do 1.536 divided by 3.11. And that is 0.493890675, according to my calculator. And then 4 minus -3 is 7. This is not in scientific notation, so I'm going to move the decimal to just after the 4. And while I'm at it, I'm going to round to 3 decimal places. The 8 rounds up to a 9 because it's got a number bigger than 5 that comes after it. And since I made this one bigger by 1, I need to make this one smaller by 1, 10 to the 6th. So it's 4.939 times 10 to the 6th. Okay, just go through a couple more examples, 3 more examples, where we've got to decide what to do. Should we multiply or should we divide? The sun is 1.49 times 10 to the 11th meters away. Light travels from the sun to the earth at a rate of 2.99 times 10 to the 8 meters per second. Use the formula time equals distance over speed. Well, that's nice. It tells us how to do this one division. To find out the time required for light to travel from the sun to the earth. All right, 1.49 divided by 2.99, divide the factors. We get 0.498 times 10 to the 11 minus 8 is 3. This gets changed to scientific notation. Actually, I would, I just put it in regular notation here, or standard notation. This is 498 seconds, which is 8 minutes and 18 seconds. That's the amount of time it takes light to get to the earth from the sun. How many times greater is the mass of a proton than that of an electron? We are comparing to the electron, so we want to do the mass of the proton compared to the mass of the electron. the mass of the proton, 1.67 times 10 to the negative 27, and the electron's 9.11 times 10 to the minus 31. And if we divide that, the 1.67 divided by 9.11 gives us 0.1833, and then it'll be times 10 to the negative 27 minus negative 31 is 4. We change this to scientific notation. I'm going to actually change it to standard notation here, because it's just 1,833 times. When you are talking about the mass of an atom, they tend to ignore the mass of the electron because it's so much smaller than the proton and neutron that it doesn't really, it doesn't effectively contribute to the mass. I mean, technically it does contribute to it, but not much. How far does light travel in one day if the speed of light is 2.99 times 10 to the 8 meters per second, and one day is 8.64 times 10 to the 4 seconds long? We're going to take that rate and multiply it by time. So this is going to be multiplication. The speed of light multiplied by 8.64 times 10 to the 4th. Let's multiply the factors together. 2.99 multiplied by 8.64 gives us 25.8336 times 10 to the 4 plus 8 is 12. Change to scientific notation. I'm going to go ahead and do a little bit of rounding here. 2.583. That number got smaller by 1. This one's going to have to get bigger by 1. And this would be how far light travels in one day. 2.583 times 10 to the 13 meters. All right, in the practice, number 1, you're going to be practicing multiplication and division. Number 2, you get some situation problems where you've got to decide whether to multiply or divide, and then do that. Number 3, you're going to find the volume of the Earth, find its density, and compare that to the density of a nucleus of an atom. Number 4, find out how old Horus is in days and years and days. 5 is a triangle angle problem. 6, find the slope 3 times. 7, you're going to be doing exponents on scientific notation. Just apply the exponent rules where you'll distribute that exponent and then put it in scientific notation. Then number 8 has you calculate the speed of light from Einstein's famous equation, E equals mc squared.